Hi everyone, good afternoon. How are you all? I'm Dhwani from Geeks for Geeks and I will be the host for today's session. Let's just wait for a few seconds so that more people can join in. Just give me a thumbs up in the chat if I'm perfectly audible and visible. For today's session, we have a lot in store for all of you data science enthusiasts out there. And I'm sure you all will learn a lot from today's session because we have a very experienced speaker with us. I would like to welcome Rehan. Hi, Rehan.
Hi everyone.
How
Thanks
are
for
you?
joining everyone. Yeah, I'm doing good. How are you and
So,
how is everyone
Rehan,
doing?
I'm sure everybody is great and really, looking forward to this session. It's really great to have you here. So, for those of you watching us, Rehan here is our course mentor for the course that Geeks for Geeks is going to provide that is about data science. So, Rehan will tell us something about what exactly data science is and what the course will entail. And you can all avail the discount on this course by using this coupon, and you may want to take a screenshot of it, and once we start, Rehan will tell you what the course is all about and what exactly does data science, like what's the significance of data science in today's world. So over to you, Rehan.
Yep, thanks Zani. So yeah, thanks everyone for joining. So yeah, I'd be discussing about what this course will be having in store for you. So it will be covering the fundamentals of data science, right? So tools that you'll be using for data analysis, for visualizations, and also the later part of the course will be covering machine learning and different machine learning algorithms which you can use for making predictions and informed decisions. And then the last segment will be covering deep learning, which will be involving covering the basic neural networks like CNN, LSTM, so all those things. So yeah, this will be a brief overview of the course, and you can go into detail like by going to the course link and going to the syllabus. Yep, Dhani. So yeah, this is what is the course structure will look like.
Right. So you can all refer to this course link in the description of this video and you will get the discount coupon there only. So Rehan, for those of the people who are watching this, who are just getting introduced to the term data science, can you give us a brief introduction of what exactly it is all about and what is its significance in today's industry?
Yep, sure. Actually, data science is about, it's very broad field, and it is about making insights from the data that you have, making meaningful insights, so that, and using the tools, data analysis tools, different platforms, so that, you can make informed decisions for the business. Uh, so, for that, you need to be proficient in like some of the skills, right? Like you need to be like in having knowledge of programming, so it should be Python, R, or JavaScript. You need to have like knowledge on SQL databases. How do you like store the data and you like retrieve it effectively, right? You need to have knowledge of different data visualization tools where you can visualize the data that you have, different data analysis tools where you can have insights about the data. Yeah, this is what data science in broad is all about. Then you have different facets to it, like you have machine learning, right? Where it is more of you have the data, which you feed into a model which will be learning something and which will be doing the prediction for the future. So then you have deep learning where you further you can like if like you have a more complex problem, so just using the raw data which machine learning is not able to solve, so you can use that to like train a model, and then like it can also like provide the prediction for that. So it depends on the use cases that you have. So that's why it's very important to know. You cannot be expert in all the like field. I mean all the subfields, but it is very important to know about like different data science tools, machine learning tools, and deep learning, so that I mean when it comes to like a business problem and the goal, so you are able to use right amount of tool and able to eliminate the others, and you're not just using the tools what you have at hand and what like knowledge you have. Okay.
Right. So before we dive into the, like more topic oriented concepts, can you give us a basic difference between data mining, data profiling, and data analysis? I mean, this question has I've heard a lot of times people mix these terms a lot. So what is the difference in all these terms?
Yeah, so data profiling, I mean, it is more about, I mean, you have the data and I mean, you are summarizing the information, you are like evaluating it. And so basically, I mean, it will be used to uh, like find the missing values, incorrect values, right? So, I mean, this is like what profiling is all about. Mining is more focused on like how you are able to get the useful information from the data. So it is, you can say, one step ahead of like deep diving of the profiling. And data analysis and mining, you can, I mean, use this interchangeably. That I mean, and for this data mining, you need to use some like advanced data analysis tools for like rapid miner and all those, so that I mean you can get the like the insights what you're looking out.
Right. So I guess this clarifies a lot for a lot of people, like who confuse these terms a lot. Because I personally have talked to a lot of people who show interest in data science, but they are mostly confused about what the terminology is all about. So let's just dive into what, like the more topic oriented concepts. So can you tell us about what a vanishing gradient is?
Yeah, so for like vanishing gradient, I mean, it is like we can say, I mean, it is more related to like specific to machine learning. So it will not be used for like traditional data science methods or statistics method that we'll be using. So what happens? I mean, whenever like just to give a small background, like short background, that whenever you're training a model, right, to learn anything, so it is just like training a kid of like any new thing that you are trying to teach, right? So the model will learn using this the trial and error. So you will be giving him like some input. It will be like doing some prediction, and then it will be calculating the difference between what it predicted and what the actually the right answer was. So you'll be providing both the right answer, and then you'll be seeing the prediction. You'll be seeing what is the difference, and then again you train the model, and model fine tunes itself. So with vanishing gradient, I mean, what happens that like when the loss, the so what is the difference between the actual prediction and the right answer? So that is called a loss, right? So like if the gradient, so I mean if the gradient of the loss, I mean, it is around zero. So what happens? I mean, then you are not able to train the model. So if you like form a mathematical equation and then you have a coefficient, I mean, which is very small, so it will become, if it is approaching to zero, right? So then it will become very hard for you to train the model. How we can like avoid these situations? I mean, you can have different activation functions. You can use ReLU to like avoid this problem. You can use like batch normalization, so that I mean you are fitting those values which are approaching to zero within a range, so that I mean the like it is not approaching to zero and the model can learn. So I mean we can further deep dive in the course, I mean, how this like vanishing gradient works, and how does the model learn, what is the activation function, what is batch normalization, what are different types of activation functions.
Right. So what's basically a unit architecture?
Yeah, so unit, I mean, it is actually based on the like based on CNN, convolution neural network. So so now I mean like I mean why do we have it, right? So like suppose you want to, like you have any image of cat and dog, right? Normally the example that you see, and you want to classify them into different classes, cats and dogs. So I mean you can use a simple CNN, convolution neural network, which will be processing those images, like the image they'll be having in the form of metrics, and they will train, it will be like this is actually very much particular to deep learning. So CNN is a type of deep learning model which is used for images. It can be used for data also, but I mean that is like you have to provide a three-dimensional data and all. So, but like normally we are using it for images. So what happens when you're using, like when you want to classify different, like just for example, different like dogs and cats, and you want to classify, you train the model. That is very easy to do. But now suppose what happens that I mean you want to detect.
Rehan, I'm so sorry to interrupt. Your video is lagging and your voice is cracking. Can you rejoin?
Sure, sure.
Yeah, great.
Sorry for
Thank
that.
you. Right. So, till the time he joins back, for all of you who are watching this, what is your experience with data science? And if you have any particular questions that you want to ask the mentor of this course, you can just type them in the comments and I'll make sure to cover as many questions as possible. And you can tell us about what your experience is with data science and what was the thing that introduced you to data science. So, yeah, Rehan, now you're good to go.
Yeah, I'm sorry. I think the network is fine. I mean, the speed, what I can see, I can, maybe the issue is with the like rendering of the video, maybe.
Oh,
So I'm
okay.
going
I
to,
don't know.
yeah,
Okay, you
no
can go
worries.
on.
Yep. So now suppose what I need to do, like I'll just give you an example that you have different defects in a so in manufacturing, in the quality control, in the QA line, uh, uh, like you can see different objects are there, and the workers have to manually sort out the like good objects so that they can go for like shipping, and they have to remove the defective piece out, right? And the defects can be very minute, right? If I say a pen, right? So ballpoint pen, like if you don't have that like wax which is very minute, if you don't have that, is considered as a defect. If you have the rubber grip which is torn, that is a defect, right? So now suppose we were good with CNN, right? And when we wanted to do the image classification, but if we want to like see these like come down to this level of minute detail that we want to identify those defects, right? So then we have to go with the approach that we need to just focus where we have to localize where is that defect, and for that one, what we need to use a semantic segmentation. So what is semantic segmentation? It is going to the pixel level and identifying those defects or those objects. So I mean in like deep learning terms, anything is an object, right? So that defect is object for me, for us. So unit architecture, it is used for the semantic segmentation, right? Uh, it is based on the convolution neural network, and it's, I mean, it is having a particular architecture, so it is suitable for identifying those like pixel level segmentation. It is used for doing that. Thank you.
Right. So, how is RNN different from LSTM?
Okay. Uh, so like we have a normal neural network, what we have, right? So I mean, if you're not having background of like neural networks, deep learning, so it is fine if you're not able to understand these terms. I mean, the intent why we want to like discuss about all these things is to give you a brief overview of what will this course be about, right? If you find any difficulty in like understanding these terms and all, right? I mean, you can just post your questions. Yeah. So coming back to the topic, so yeah, now why we have like the RNN and the LSTM. So RNN is the recurrent neural network, right? It is different from normal neural network. So here what we have, the output, whatever is the output, it is going back to the input, right? So it is used for suppose you want to use a speech data, or you want to have a time series data, right, where you want to see what is the pattern which is going on. So for that we are using. And how it is different from LSTM, that in LSTM, which is long short term memory model, it is a type of RNN actually. But here, I mean, you have a special architecture and special units. I mean, you have like something called forget gates. I would not go into the details. What it does, it will be so in typical neural network, what happens, so you can understand neural networks as a collection of neurons, and you are passing the information to different neurons, and then I mean it is like the whole network is learning something. So it is just like how a neural system works, right? Not exactly same, but similar to that. So what normally happens in a neural network, you feed the information, and I mean you feed a word, and you like predict the meaning. I mean it will be just learning that. You feed the next input, it will be losing what you fed previously, right? But what happens with the LSTM? So suppose, I mean, you have a sentence, right? Today is a sunny day. uh, so now you suppose, if you want to interpret this whole world, right, you want to interpret the meaning of this whole world, so you have to also look at the information what is there at the back. So like normally, like a good example would be Alexa when you're using, right? So whatever you are saying to Alexa, I mean, it is processing your whole speech, uh, all the information. So if you want to make use of the previous data also, then I mean, yeah, we are using the LSTM. We are like for natural language processing, and it is used to retain the information as compared to a normal neural network, which is like not having the temporal or the like the information in that. So I mean, it is having a memory cell which can remember the previous information and can connect the previous input and the current input to make the sentiment analysis for the whole historical and the present.
Right. So I guess that's a lot of terms you know, I mean, I personally need to go through. So what is bagging and boosting?
Um, yeah. So, I mean, we have something called ensemble learning. Uh, so, I mean, like to dive deeper into this, yeah, we should go through the background and the basics. Uh, but I mean, I'll try my best if we can, like, just like not go much into technical details, so that I mean, it is easy for you to understand. So, something is ensemble learning. So, ensemble learning means we talk about one model for learning something, right? You can say cats and dogs, right? But suppose you have you also want to identify like some other scenario that where I mean like food also. So you might or some other thing, I mean, which you cannot club into like same model, right? So ensemble learning means combining two models to have some results, right? So in that case, I mean, the bagging, I mean, it is that, I mean, you are like decreasing the variance, right? Like in the prediction, and I mean, and you are generating the additional data, right? So from the original data set. And but boosting, on the other hand, I mean, it is the iterative process, so that I mean, you can adjust the weight based on the last classification that you're having.
Right. So can you tell us the difference between CNN and RCNN?
Yeah. So we discussed about um, CNN, that it is used for image classification. It uses image as a matrix, and it is used to, I mean, it can process the image. And we discussed about RNN, which is used for like holding the temporal or the like the past information. So when we want to, like when we combine these two things, so CNN and RNN, we have something called, which is RCNN, right? So I mean, the main difference would be that, I mean, like RCNN will be similar to CNN. The only thing is that it will be able to hold the like temporal information or the previous information which is coming in the sequence to form the judgment based on the past and the current value, uh, in contrast to the CNN, which was just processing each input mutually exclusive or independent of the previous input which was coming.
Right. So what exactly is the purpose of using a residual layer?
Yeah. So, I mean, if we study about like a ResNet model, or which is a like, so there we have the residual layer, and I mean, um, so like, so what happens? Uh, uh, so I we discussed about vanishing gradient problem, right? Where I mean, the model is not able to learn. So what happens in the residual layer, right? I mean, you have the residual connections, right? So what it does, I mean, it will be skipping some of the layers, right? And it will be providing a path so that, I mean, it can connect from the the previous to the later parts when you are skipping some layers. So what happens, I mean, like the knowledge distillation, what we say that, like how we are, so you have multiple layers of in a neural network, and what happens whenever you pass information, there is knowledge distillation which is happening. But in turn, what happens, also, I mean, if you in some cases, like what we discussed about the vanishing gradient, so to avoid those things and to make our network simple, right? Because, I mean, more layers means mathematically we are having like more equations, and, I mean, it can also lead to something we'll discuss later, overfitting also. So then, I mean, yeah, we are skipping some of the layers, also at the same time preserving the knowledge that you're passing to the model.
Right. So, since you mentioned, we'll be discussing. So, what's the difference between overfitting and underfitting?
Okay, so overfitting and underfitting, it is something like overfitting, as the word denotes, it is that what you have done, you have trained a model, so uh, with some limited set of data, and it is performing very good on that, right? And you have not provided some. So suppose if I would say, I mean, you are training on uh, bikes, right? So, I mean, you have just trained on like some sort of bikes, right? A simple time, and when it sees a scooter, it confuses what it is, and when it sees like a big sports bike, it confuses what it is, because it is just trained on a small, like, normal bike. So what we say, then it is overfitted to like that particular data set. Underfitting, what happens that, I mean, when you provide diverse amount of data, but there is no pattern in the data, right? So what happens, I mean, it will be it will be generalizing, and it will not be performing on like any of the subsets. So, I mean, that is like it is that is the difference between overfitting and.
Right. So, a lot of people in the chat are asking about what's the proper route to becoming a data scientist. If you're just starting the field. So, can you just like give a brief overview about that?
Okay, proper like route that we should be using to for data science, right? uh, so, I mean, as I discussed in the beginning, so the skill set or the tools, I mean that you should be using, like you should be aware of that. So, I mean, first of all, you should be having very good domain knowledge, like on what, I mean, you're going to work. Like you should be having good programming knowledge, like or Python or R or any tool that you're using. You should be good with databases, writing SQL queries, procedures, and having those basics cleared out. Then you should be like planning to like learn any data analysis tools, right? Learn the basics of statistics, machine learning, right? The like and different data visualization tools like Tableau, QuickView, Power BI, right? So, and how do you create the like business reports using that? So, in short, right, like, I mean, having all these tools and knowledge, try to come up with a like build a project of your own, and yeah, you can then you can have a like good idea, and also you can transition into data science role.
Right. So since you mentioned that, like working on platforms is really important. So what, according to you, are the top three platforms for data scientists?
Yes, so the most popular one, I think everyone might be aware of, is Anaconda, right? So there, I mean, you have a lot of libraries which you can use for data science. You have S2O, you have, I mean, Databricks, you have RapidMiner. So, I mean, a lot of platforms are available. I mean, you can stick to one platform, and, I mean, and you can perform, I mean, all the like business analysis. I mean, you can consider a use case, first of all, a real time use case, and you can use any of these tools for having those predictions, visualizations, data cleaning, all those.
Right. So, what's your favorite environment to code data science projects in?
Yeah, I mean, I use Anaconda, and I also use Jupyter Notebook sometimes because when I'm working on a deep learning project and I want to do some visualization on that, I use Jupyter Notebook to do the visualization. And for visualizations, like I'm also using Kibana for that, and Power BI, Power BI also for that. So Power BI is having very good integration with Azure. And if any one of you is working with machine learning, so whenever you want to create reports and all for so you can use Power BI, and also it has good integration with Azure Machine Learning Service. So it depends on what is the use case that you have, so you can use the environment according.
Right. So, what's the advantage of using deep learning algorithms over machine learning?
um, uh, so for uh, uh, so for deep learning, I would say the biggest advantage we have is so for machine learning you need to suppose I need to say that okay, that we have some certain amount of data, and we have to get some amount of data for the vehicle speed and acceleration, braking, all those things, and having the data about the driver driving pattern, and to determine if the driver is driving rash or normally, or it is slow, and we can based on the data, what is the driving pattern, we can provide some alerts of a potential accident that might happen. If I take the case of machine learning, what happens? You need to manually engineer the features that, okay, braking, you need to manually define the threshold. Acceleration, it has to be in such and such limit. So you need to do a lot of manual feature engineering in machine learning to do that. And for that, you need to have good domain knowledge of, driving, speeding, braking, all those things. What is the ideal pressure on the gas pedal and all those things? What should be the angle? Very minute details. But for deep learning, why it became popular? Because you can just feed in the raw data, and by raw data, I don't mean that just you feed in data. Still you need to do some data processing. You need to have the data in certain format. You need to clean the data, but you need not manually provide your ranges for speed and braking, and like in what time you're braking, your acceleration and deceleration, all those values. But you can provide your inputs, and you can just assign them some labels. Okay, this is a rash driving, this is a normal driving, and it will be automatically, it will be detecting the features and giving you. So the advantage will be that you don't have to do manual engineering, and you can have good predictions uh, using the raw data instead of being feature engineering.
Right. So, is there any case where machine learning algorithms outperform the deep learning algorithms?
Yeah, definitely. Because for deep learning, when we say deep learning and it is giving prediction, also it is data hungry. You need to provide a lot of data for deep learning to, work, and for the neurons, to learn. So, if we have a simple use case and you have less amount of data, machine learning algorithm will be faster, and it can be some suppose you have a normal case of linear regression or logistic regression, right? You have certain buying patterns of the users, right, on certain days, and then you want to predict on which day is the so you can use simple machine learning, or even you can use simple statistics in that case, right? So yeah, we should be aware of. What is our goal? What is the the cost? What is the cost we have, right? So uh, never. This deep learning or machine learning will be the best thing. It will depend on the scenario that we have.
Right. So, now this is a question that a lot of people ask. I personally heard a lot of people ask this question. Can someone make a career in data science without having a good knowledge of mathematics?
Uh, whenever I I mean, yeah, this is a good question, and I mean because I am conducting a lot of interviews for data scientists, machine learning engineer, deep learning engineers, and computer visions, and so I mean, what I would say that I mean you need not be expert in when we say mathematics. I mean it is related to probability, statistics, and like only certain areas of mathematics that we need. Uh, so you should not be expert, but I mean, if like that candidate or that person is having a fundamental understanding on, we were discussing about vanishing gradient, we were discussing about overfitting, underfitting, right? Activation function. If you have a mathematical knowledge of that understanding, like then I mean you can I mean you're good to use any advanced tools and all, right? So but even I mean if you don't have a very advanced knowledge, if you have the fundamental knowledge, I mean that is a good thing. But what I would advise that like if I mean if like you are like aiming to be a data scientist or like any role in the data science, try to have knowledge of basic probability, statistics, and some like areas which are needed because at the end, I mean, you can't avoid it. Because you need to actually, whenever you are like doing the data analysis, making predictions, like having the missing values, like finding the means, median, all those things. I mean, you need to have those basic concepts clear. So I would strongly recommend fundamental knowledge in mathematics.
Right. So, what's the difference between a project that we do on our own and projects that are implemented in the industries? I mean, I understand the scope is different, but what's the difference in your personal role in the project?
Uh, I mean, first of all, like the project, I mean, that we are doing on our own and the like in the industry. So, suppose if I'm doing simple car plate detection, right? So if I'm doing a personal project, I'll be getting some good car plate images from the internet, from like you can say a Kaggle dataset. So Kaggle is a like platform where you can compete for different like data science and deep learning challenges, right? uh, and you can like practice and train the model and you can, but if I say industry or the real time use case, and if I'm getting some images from the for the car plate, what may happen? I mean, there might be sunlight glare, the images are not clear. There might be images which I'm getting, which it is at the night, which is having the headlight glare. So, and also, what happens in my personal project, my accuracy of the model will never change. But in the like in the real life, what will happen? I mean, there will be drift in the data set, the patterns, right? So like I mean the main difference would be the real time use cases, the scale, the different edge cases which you might be facing in the industry.
Right. So, I guess that's it for the questions that I have, Rehan. Thank you so much for, like telling us all about data science and clarifying so many of my doubts. So for those of you who are watching this session who joined late, don't worry. You can, like enroll in this course, and you can use this code. You maybe want to take a screenshot of it. You can use this code to actually get a flat 2000 rupees discount on the course. And the course mentor will be Rehan, so I'm sure he'll be able to clarify all your doubts personally there. So be sure to, like enroll into this course and avail the maximum benefit out of it. Thank you so much, Rehan, for your time and for such an informative session. I'm sure everybody learned a lot from you. So I guess thank you so much. Have a great day
Thanks.
ahead.
Yeah, thanks a lot for everyone for joining. Yeah, it's my pleasure. Thank you. Bye.
Thank you. Bye bye.